Hey guys, in this video you're going to write your first C++ program, so sit back, relax, and well, enjoy the show. Hey, if you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. I'm gonna tell you why you need to learn C++. C++ is a fast language, like really fast. It's commonly used in advanced graphics applications. A few examples would include Adobe applications, video editing software, anything that's graphics intensive. C++ is considered a middle-level language, therefore it's commonly used with embedded systems. And most importantly, it's commonly used with creating video games. I like video games. Like a lot. Compared to other programming languages, you could say that C++ is a middle-level language. Programming languages tend to be on a spectrum. The higher level of programming languages, the more it resembles human language. Languages that are closer to being lower level resemble hardware instructions. Higher level languages such as Python, Java, and C# are very easy to write with and to understand, but they tend to be slower. C++ and C, they take a little more effort to write, but they're very fast. They have the benefit of working closely with machine hardware while still somewhat resembling human language. Just a fair warning, there is a learning curve with C++, but if you can learn it, it's worth it. There's two things you'll need to get started. One is a text editor. A few options include, but are not limited to, would be VS Code, Code Blocks, or even Notepad. VS Code and Code Blocks are also considered IDEs, Integrated Development Environments. They are a text editor as well as a workshop that contain a lot of useful developer tools. In this video, I'm going to show you how to download VS Code, but feel free to use any text editor that you're comfortable with. Secondly, we'll need a compiler. A compiler is a piece of software that will parse source code to machine instructions. And that's really it. If you're using Windows or Linux, you'll probably want to go with GCC. If you're running Mac, you'll probably go with Clang. Okay, Clang has a really cool logo. It's Blue Eyes White Dragon. So let's get started. Well, alright then everybody. Now we are going to download VS Code, that text editor I was talking about. Head to this URL, code.visualstudio.com. Then select the correct download for your operating system. I'm running Windows, I'll select Windows. Then I will open this. Read the agreement. Yes, I actually did read it that fast. I accept the agreement. Next. 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 I'll create a desktop icon, why not? Next. And install. We might as well launch it. Finish. In VS Code, there's two extensions I would recommend. Go to the left toolbar, underneath Extensions, we will look up C/C++, and we would like to download this extension. Let's pretend that this wasn't already installed. So I'm going to install it. Then the next extension I recommend is Code Runner. Here it is. Then just click this blue button to install it. Okay, let's close out of this. We're going to create a new folder to hold our C++ projects. Go to the left toolbar, Explore, Open Folder. I'll create a new folder on my desktop. New folder. I'll name this C++ Projects. That sounds good to me. Then select folder. Within this folder, we'll create a new file. I'll name this helloworld.cpp. Make sure to get that CPP extension at the end. That means it's a C++ file. Okay, we now have a C++ file to work with. Now we just need to download that compiler that parses source code to machine instructions. There's a great set of instructions at this URL, code.visualstudio.com/docs. Let's head to C++. There's different installation instructions depending on your operating system. You'll be downloading GCC on Linux if you're running Linux, GCC on Windows for Windows, and Clang for Mac OS. Downloading a compiler for Linux and Mac is actually really easy. I can cover that in like 30 seconds. Windows is a little more complicated, but let's begin with Linux. So all you're going to do is open up Terminal and enter the following command, gcc/v. That will check to see if it's currently installed. If it's not, you enter this command in. Then you install the GNU compiler tools by typing in this command right here. And that's all you need to do with Linux. If you're on Mac, you'll download Clang, open Terminal, type in this command. If Clang isn't installed, all you type is this command, and that's it. So pretty easy, right? If you're using the Windows operating system, there's way more steps. So let's head to step 3. We'll need to install MinGW W64. You can click this link to the installer. This is an executable. I'll open this when it's done. Click Next, Next, Next. Wait for it. We might as well run this. Then finish. Now we will follow the installation instructions on this website. Under step 5, we will type pacman capital SYU, enter. Type Y, then enter to proceed with the installation. Type Y, then enter again to confirm to proceed. Now we'll need to find this program from the start menu. msys2, then type this command, pacman-su, enter. Type Y, then enter to proceed with the installation. Now we'll need to enter this command in. There's a lot to type here. pacman-s needed base dev l min gw w64 x86 underscore 64 tool chain, then enter. Then just hit enter. Proceed with the installation, type yes, type Y, enter again, then give it a moment. Then we can close out of this window. We'll have to find the bin folder of MinGW. It's likely going to be within your C drive. Go to msys64, MinGW64, bin, then copy this address. We'll need to add that path to the Windows path environment variable. To do so, search Settings, Settings. We'll search Edit Environment Variables. Go to Path, Edit. Let's pretend that this wasn't here. I'm going to go to New, paste that address. OK. OK. Close out of this window. Just to be sure that our compiler is working and available, let's open up Command Prompt. Command Prompt. Then type in this command, g++ --version. Enter. Yeah, it looks like it's good to go. We have now successfully installed our compiler. All right, everybody, let's write our first C++ program. At the top of our C++ file, we are going to type include, within angle brackets, iostream. iostream is a header file that contains functions for basic input and output operations. By writing include iostream, we're including that header file. Then we have access to a whole bunch of useful input and output operations. Now we'll need a main function. The main function is where the program begins. We'll type int main, parentheses, curly braces. We begin the program by invoking the main function, and read any code within the main function, starting at the top and working our way down. At the end of our main function, we'll want return 0, then add a semicolon. If we reach return 0, that means there were no problems in this program. However, if 1 is returned, that means there was a problem, there was an issue. So place return 0 at the end of your main function. What we'll do in this lesson is write some basic output. To write some output, you'll type std. Contrary to what you might believe, in this case it doesn't mean sexually transmitted diseases. It means standard. Follow std with 2 colons, then type cout. C means character, out means output. Altogether, this means standard character output. We're going to display some characters as output. Then follow cout with 2 left angle brackets. These characters mean output. It's also known as the left shift operator when used with numbers. What characters would we like to display as output? Within quotation marks, let's write something. What's a food you like? I like pizza. I'll type that. Then follow this statement with a semicolon. At the end of statements, we add a semicolon. That lets the compiler know that this statement is done. It's sort of like the period at the end of a sentence. That's when you know the sentence is complete. So I'm going to save this. I'll hold Control S, or you can go to File, Save, then click this button to run it. And there's my output. I like pizza. On the next line, I'll type std, 2 colons, cout, 2 left angle brackets for output. I'll write a second line. It's really good. Then I'll run this again. You can press this icon to clear your output. Uh-oh, we have a problem. I like pizza, it's really good. All of this text is on one line. What if you need the next line of text to be on, well, the next line? When you need to move your cursor down to the next line, you can follow some string of text with double left angle brackets for output, std, colon, endl. That means end line. And I'll do the same for my second line. I'm going to save, clear my output, run this again. Yeah, there we go. I like pizza, it's really good. Each line of text is on a different line. Another option for a new line that's better performance-wise is to add a new line character. Within single quotes, type \n. And let's replace that here as well. So I'm going to save, clear my output, run this again. I like pizza, it's really good. Adding a new line character does the same thing, and it's better performance-wise. However, the benefit of using endline is that endline will flush the output buffer. Really, you can use either one, but I thought that might be a nice trick to show you. Now, you can write a comment. A comment is ignored by the compiler. To write a comment, you use 2 forward slashes. This is a comment. Comments are used for yourself for notes, or for notes for another developer. So if I were to run this again, this comment is ignored. It's not used as output or anything like that. If you need a multi-line comment, you type ****. Wherever you need your comment to end, you'll place */ again. This is a multi-line comment. And you can see that all of this is ignored as well. So comments are used as notes for yourself or for other developers. Yeah, that's a quick introduction to getting started with C++. I'll post this code in the comment section down below if you would like a copy. Hey, if you enjoyed this video, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, I'm gonna explain what variables are. A variable you probably remember from middle school math class. A variable is a representation of some number or value. There are 2 steps to creating and using a variable: declaration and assignment. We'll begin with declaration. To declare a variable, we need to list the data type of what we're storing exactly. In programming, you can store more than just numbers. You can store characters, even whole sentences, etc. Let's work with whole numbers. To store a whole number, we will type int for integer. Then we need a unique identifier for this variable. For now, let's just say x. We're used to working with like x and y in math class, right? We will end the statement with a semicolon. This step is declaration. Now to assign a variable, you take the variable's name, that unique identifier, then we will set this equal to some number. Since we declared this variable as an int, it will store an integer, maybe like 5. Now this variable behaves as if it was the value that it contains. It will behave as if it was the number 5. Then to display a variable, we can use standard output. std cout. We will display x. And let's see what we have. there's our value, 5. This first step is declaration. The second step is assignment. The nice thing about doing this in 2 steps is that you can later assign your variable a value. If you know what value you would like to give your variable right away, you can do that at the beginning of your program. You could combine both of those steps. Int x equals 5. And that would do the same thing. In cases where you don't know what value you would like to give a variable, you could assign it later, such as when you accept user input. You don't know what the user is going to type. So let's create another. Int y equals 6. Then let's display whatever y is. I'll add a new line. Let's copy this, paste it. Okay. X is 5, y is 6. We could even do something like this. Let's say int sum equals x plus y. Then we'll display whatever our sum variable is. Cout sum. The sum of x plus y is 11. Now there's different data types depending on what you need to store within a variable exactly. The int data type stores a whole integer. Let's think of a few examples of whole integers. What about an age? That's typically a whole number. Int age equals 21. Let's think of 2 more examples. What about a year? Int year equals 2023. How about days? Int days equals 7. The int data type can only store a whole number. With days, what if we assign this a value of 7.5? Let me show you what happens. Alright, I will display days. Alright, that decimal portion is truncated. When I display days and we attempt to assign 7.5, well, this variable can't store that decimal, so it's truncated. If you need a number that includes a decimal portion, there's a different data type for that. And that is a double. This is a number including decimal. A few examples of a double would be maybe a price. There's dollars and cents. Double price equals $10.99. What about a GPA, a grade point average? That includes a decimal. Double GPA equals 2.5. Then maybe a temperature. Double temperature equals 25.1. I guess this could be in either Celsius or Fahrenheit. Then let's display maybe price. Price. Yeah, and that decimal portion is not truncated, much like what you see with whole integers. If you need a number that includes a decimal portion, use a double. Now we have the char data type. That stores a single character. Type char. Maybe we're working with student grades. I'll name this variable grade. Equals. Then to store a single character, you use single quotes. This student has an A. 2 more examples. What about an initial? Singular, not initials. Char, initial. What about B? So I'm going to display initial. Initial. Okay, we have our single character of B. Now check this out. What if I attempt to store more than one character? I'll add C. We have a warning. We have an overflow in conversion from int to char. So what's displayed is the last character, just C. So chars can only store a single character. Here's one more example of a char data type. What if we're working with currency? What type of currency will we work with? Char currency equals maybe a $sign. If we're working with a different type of currency, we could change this to a different symbol. Yeah, that's the char data type. It stores a single character. Next on our list is booleans. Boolean. A variable that's boolean has only 2 states, true or false. To create a boolean variable, you type bool, then a variable name. So these are applicable to anything that has 2 states. What if somebody is a student? They're either a student or not a student. Bool student equals true. If they're not enrolled in classes or they graduated, you could set this to be false. Think of a light switch. The light switch can either be on or off. You could say a light switch is Boolean. There's only two states, true or false. How about bool power? Is something powered on or not? Power equals true. If it's turned off, that could be false. Maybe we have a store and we need to mark if something is for sale or not. Like, is it available? Bool for sale equals true. If an item in our store isn't for sale, like it's not available, we could set this to be false. So that's the idea behind Boolean values. It has two states, true or false. The last data type I'll cover is strings. A string is technically an object that represents a sequence of text. Think of it as the char data type, but we can store more than one character, even whole sentences, like a name or an address. Strings are provided from the standard namespace. To declare a string, we would type standard string, then a variable name. What about just name, like we're storing a user's name? Place your text within a set of double quotes. Then why don't you type your first name? Then we will store that within this variable name. Then to test it, let's display it. Standard output, we will display name. And there is your first name. Let's create a couple more examples. What about a day of the week? Standard string day. Then pick a day. I like Friday. What about food? Standard string food. I like pizza. I'll store this series of text as a string. Then maybe an address. Standard string address equals, make up some address, 123 Fake Street. Basically speaking, a string is a type of object that represents a sequence of text, such as a name, a day, an address, etc. Now I'm going to show you how we can display a variable along with some text. I would like to display hello, then whatever your name is. I will type what is known as a string literal. We're literally printing a string. Hello. Follow this string of text with a variable. My variable name is good. Then let's display it. Hello, then whatever your first name is. But you do have to pay attention to spacing. After my word hello, I'm going to add a space. There. Hello, bro. Then let's display our age. So I'm going to add a new line character. Standard output, we will display you are age years old. There. Hello, bro. You are 21 years old. Make sure to pay attention to the spacing as well, because it's easy to mess that up. Alright, so those are variables. We covered a few of the basic data types, but there's more advanced data types once we gain a little bit more experience with this that I'll cover. We have integers, which store a whole number, doubles, which are numbers that include a decimal portion, chars are single characters, booleans are either true or false, then strings represent a sequence of text. An important note with strings is that you can include numbers, but they're treated differently. So yeah, those are variables in C++. Your assignment is to, in the comments section, post a integer variable, a double, a character, boolean, and a string. Think of some examples, preferably some examples that I may have not covered already. That would be good practice. Well, yeah, and that's an introduction to variables in C++. Alright, welcome back everybody. In this video, we're going to discuss the const keyword. The const keyword specifies that a variable's value is constant. It tells the compiler to prevent anything from modifying it so that it's effectively read-only. Here's an example. Let's create a program to calculate the circumference of a circle. We'll first define the variables that we'll need. We have double pi. Pi equals 3.14159. Then we have double radius. Pick some radius. I'll pick 10. Then double circumference equals, and here's the formula to calculate the circumference of a circle. It's 2 times pi times radius. Then we will display our circumference. Standard output, we will display circumference. Then I'll add maybe centimeters. Our circumference is 62.83 centimeters. Any variable we do not want to be able to be changed at all, we can turn into a constant. Let's say that somebody goes into our program and changes pi to a different number, like 420.69. Well then, this is going to change the result of our program. We may have not realized that somebody changed the value of pi to 420.69. So any variable you do not want changed, you can prefix this keyword const. Const double pi. Now, a common naming convention for constants is to make all of the letters uppercase. So let's change pi from lowercase to all uppercase. And we'll need to make that change here as well. Now let's try and change pi to 420.69 again, and then see what happens. Okay, we have an error. Assignment of read-only variable pi. So by including constants, it adds some data security. We can't normally change any value that's a constant. A couple other examples of variables that you could turn into constants could be maybe the speed of light. Maybe you have a physics calculator. So const int light speed. The speed of light in meters per second is 299,792,458. Let's think of one more example. Perhaps you're working with screen resolutions. We have const int width of 1920, then const int height of 1080. These may be a few examples of variables you do not want to be changed or altered at all. You only want them to be read-only. Yeah, that's a const, everybody. It's a keyword that will modify a variable or some value so that it's read-only and can't be changed. You should use constants as often as possible, only if you know that a variable is not going to be changed at all. Your assignment is to think of a constant and post it in the comment section. Hey, if you're enjoying the series, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, I have a quick video on namespaces. A namespace provides a solution for preventing name conflicts, especially in larger projects. Each entity needs a unique name. A namespace allows for identically named entities as long as the namespaces are different. Now, what the heck does that mean? Suppose we have variable x equals 0. Each variable needs a unique name. I couldn't create a second variable named x and give this a different value. If I were to compile and run this program, we would run into an error. Read declaration of int x. So each entity needs a unique name, but if we use namespaces, then two or more entities can share the same name. To create a namespace, let's do so outside of the main function. I will type namespace, then some name for the namespace. Let's say first, then a set of parentheses. I could create a different version of x. I'll give this a different value, like 1. Well, this would run and compile just fine. You can have different versions of the same variable as long as they're within a different namespace. Just for fun, let's create a second namespace. Namespace second x equals 2. This is also valid. So just to demonstrate a few things, I'm going to display what x is. If I don't explicitly state what namespace we're using, we will use the local version of an entity. If I display x, x would be 0. If I would like the version of x that is found within the first namespace, I would take that entity, in this case x, prefix the namespace. Let's say first, then 2 colons. The 2 colons is known as the scope resolution operator. I'm referring to the version of x that is found within the first namespace, and that version of x has a value of 1. If I need the value of x found within the second namespace, I would precede that entity with the second namespace, followed by the scope resolution operator. So that version of x is 2. So entities can have the same name as long as they're within a different namespace. Now, one line that you may see is using namespace, then the name of a namespace. Let's say first. If we have some entity without a prefix of the namespace, it's assumed that we're using the entity found within that particular namespace. So if I was to display x while we're using namespace first, x would be 1, and I don't need to add that prefix. But if I need x found within the second namespace, I would still need to prefix it with second. X is 2. If I changed using namespace to second, it's implied we're using the second namespace, and I don't need that prefix. 2. But I still would if I need x from the first namespace. 1. Now, there's this evil line called using namespace std for standard. Now, the reason that people include this line is to save a little bit of typing. If we're using namespace std, we don't need to include that prefix when we declare strings, or we display output with cout, just for example. Like, this would still compile and run. However, the standard namespace has hundreds of different entities. Let me show you. Standard. There's a high likelihood of a naming conflict. For example, we have an entity named data. One alternative is that we could say using standard output. That will cut down on some of the repetitions. Or using standard string. It's a safer alternative to using namespace standard. In the future, I'm not going to be using namespace standard, because I would like to steer people away from that. But just in case you see that line, you know what it's there for. So in conclusion, a namespace provides a solution for preventing name conflicts. Each entity needs a unique name, and a namespace allows for identically named entities as long as the namespaces are different. So those are namespaces. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, in this topic I'm going to explain typedefs and type aliases. Now, typedef is a reserved keyword used to create an additional name for another data type. Kind of like a nickname. It's a new identifier for an existing type. One of the reasons that people use typedef is that it helps with readability and reduces typos. Here's an example. In this example, I'll need to include this header file. Include vector. Suppose we have this very long data type, and I would like to give it a nickname, an alias. I would type the keyword typedef, then list the original data type. So we're used to strings, ints, doubles. Well, here's a really complicated one. And of course, I don't expect anybody to know this at this level yet. Standard, vector, standard, pair, standard, string, int. So this is one really long data type. This could be a data type for a pair list, but I don't want to have to type all of this. So what I could do is give this data type an alias using this typedef keyword. After the original data type, I'll come up with a new name, a new identifier. Let's say pair list. That's a lot easier to write than all of this for the data type. A common convention when using the typedef keyword, the new identifier usually ends with _t for type. Now suppose I declare a variable of this data type. Standard vector, standard pair, standard string int. Let's say the name is pair list. In place of using the original data type, we can use the new identifier. Pair list _t. So that's one of the main benefits of using the typedef keyword. We can give a new identifier to an existing data type. It helps with code readability and helps reduce typos. This data type is way beyond our level of understanding right now. Let's try some simple examples. I'll turn this line into a comment, then get rid of that. Let's create a typedef for standard strings. Typedef, then we list the original data type, standard string. In place of using standard string as the data type, I'll create a new identifier for this data type as maybe just text. Text _t. If I need to create a string, I could use this new identifier. In place of saying standard string, then maybe first name, I can replace the data type with the new identifier if I choose to. Text T. And I'll set my first name equal to whatever my first name is. Feel free to set it to your own first name. And this variable behaves exactly like a string. So let's display it. Standard output first name. And then we should have our first name. Yeah, there we are. Okay, now let's try this with an integer. Type def, we list the old data type, int. Let's create an identifier for int as number. That's more descriptive. Underscore t. Although it's more to write technically. In place of using the int data type, I could use number t. And this is technically an integer. Let's say age, then make up some age. Standard output, I will display my age, then I will add a new line. Yep, we have our first name and our age. Now, typedef has largely been replaced with the using keyword. That's because the using keyword works better with templates, which is a topic for another video. So in place of using typedef, I recommend using the using keyword. So I'm going to turn these lines into comments. Now, if we were to use the using keyword, we would type using, then the new data type. So let's say text t equals the old data type, standard string. Then let's do that with number. Using the new identifier, number t equals int. And that would work the same. We have our first name and our age. The using keyword is more popular than typedef nowadays just because it's more suitable for templates. And like I said, that's a topic for another video. All right, everybody, that is the typedef keyword and type aliases. Typedef, along with the using keyword, they're used to create an additional name, an alias, or nickname for another data type. It's a new identifier for an existing data type. It helps with readability, and it reduces typos. However, you should really only be using the typedef and using keywords when there is a clear benefit. So yeah, that is typedefs and type aliases. Your assignment is to post a typedef in the comment section down below. And well, yeah, those are typedefs and type aliases in C++. Alright everybody, welcome. We are going to discuss arithmetic operators. Arithmetic operators return the result of a specific arithmetic operation, such as addition, subtraction, multiplication, and division. Let's say we have 20 students. Int students equals 20. If a new student joins our class, we would like to add one student. Well, if we're working with the variable, we could say students equals whatever students is plus 1. Then we could display this. Standard output, I will display students. The current number of students that we have are 21. There is a shorthand way of writing this too. In place of saying students equals students plus 1, we could shorten this to students plus equals 1. That would do the same thing. 21. If we need to add 2 students, this would be students equals students plus 2, or students plus equals 2. Then we have 22 students. If you need to add 1 to a variable, you could also use the increment operator. This is another option. And the preferred way, if you only need to add 1, you would say students plus plus. We now have 21 students. You tend to see this in a lot of loops, which we'll cover later. Okay, now we have subtraction. Students equals students minus 1. There are now 19 students. We could shorten this to students minus equals 1. There are 19 students. If you need to subtract 2, we could say either students equals students minus 2 or students minus equals 2. That would do the same thing. There are 18 students. Another option is the decrement operator. If you need to decrement a variable by 1, you would say students minus minus. This only subtracts 1 from a variable. There are 19 students. So that's subtraction. To use multiplication, you use an asterisk. I'm going to double the amount of students that we have. Students equals students times 2. there are 40 students. Or we could shorten this to students times equals 2. And again, there are 40 students. For division, you use a /. I'm going to divide our class in half. Students equals students divided by 2. There are 10 students. The shorthand way is students divided by equals 2. There are 10 students. Now check this out. We have 20 students. What if I divide students by 3? We're working with an int variable, so this variable can't hold any decimal portion. 20 divided by 3, that is 6. So any decimal portion is lost, it's truncated. But if we change students to be a double, well then that decimal portion is retained. 6.66 repeating students. If you need the remainder of any division, you can use the modulus operator. Let's create a new variable. Int remainder equals students modulus 2. We'll divide our group of 20 students into groups of 2. Then I'll display the remainder. Okay, 20 divides by 2 evenly, so there's no remainder. But what if we divide students by 3 and get the remainder? Our class of students is being divided into groups of 3 for maybe like a project. But 20 doesn't divide by 3 evenly. Therefore, our remainder is 2. There will be 6 groups of 3 students and 1 group of 2 students. Now, using the modulus operator is a great way to find out if a number is even or odd. Take some value or variable you would like to check, modulus 2. If that number divides by 2 evenly, where the remainder is 0, well, it's even. If the remainder is 1, well then, it's an odd number. 21 doesn't divide by 2 evenly. So that is the modulus operator. It gives you the remainder of any division. These arithmetic operators have an order of precedence. We resolve any arithmetic operations that are first within parentheses, then multiplication and division, then lastly addition and subtraction. Perhaps we have this formula. Students equals 6 minus 5 plus 4 times 3 divided by 2. So what do we solve first in this equation? We would check any parentheses first, which there aren't any of. Then we resolve any multiplication and division. So let's go through this. So we have some multiplication here. We would resolve 4 times 3 first. That is 12. Then we have some division. 12 divided by 2 is 6. Then any addition and subtraction. 6 minus 5 is 1. 1 plus 6 is 7. And let's check to see if that's right. So students should be 7. Yep, students is 7. Now you can force operator precedence by surrounding some part of your equation with parentheses. I'll surround this part of the equation with the set of parentheses. The new result is -7. Well, yeah, everybody, those are some basic arithmetic operators. They return the result of a specific arithmetic operation. Hey, if you would like a copy of this code, I'll post this in the comments section down below and pin it to the top. And well, yeah, those are some basic arithmetic operators in C++. Hey, what's going on, everybody? In this video, I'm going to explain very basic type conversion. Type conversion is the conversion of a value of one data type to another. Two ways in which we can do this are implicit and explicit. Implicit is done automatically. If done explicitly, we precede a value with the new data type. Within a set of parentheses, you list the new data type, put it before a variable or a value. Let's perform an implicit cast. Suppose we have variable int x. I will assign x the value 3.14. Integers can only hold a whole number. If I were to display x, standard output x, well, the value is 3. We truncated the decimal portion and implicitly converted this number into an integer. What if x was of the double data type? Double x equals 3.14. Well, then we would retain that decimal portion. What would happen if I cast 3.14 as an integer, then assigned it to a double variable? Before the value, add a set of parentheses, then the new data type. I will convert 3.14 to an integer, then store it within this double, x. X now equals 3. It's a whole integer. That is one example of implicit and explicit type conversion. Here's a few other examples. I have character x equals some number, like 100. if I were to display what x was, standard output x, well, we will implicitly cast this number 100 as a character. We'll convert it using the ASCII table to whatever its equivalent is. The number 100 converted to a character is the letter D. Let's try an explicit cast. I will display the number 100 explicitly cast to a character. And that value is the letter D as output. How is this useful? Suppose we have an online exam. We have to give the user a score. How many questions did they get right, divided by how many questions were total? Let's write something like this. Int correct equals maybe 8. The user has 8 questions that are right. Int questions equals 10. There are 10 total questions. I need to calculate the score as a percentage. We could say double score equals correct divided by questions times 100. Then let's display whatever the result is. Standard output, score, then I'll add a percent sign to the end. 8 divided by 10 is 0.8, right? Times 100, that should give us 80%. We have 0%. Well, that's because we're using integer division. Questions is of the int data type. When we're dividing 8 by 10, we're truncating that decimal portion. We're getting rid of it, then multiplying whatever remains by 100. I'm going to explicitly cast questions as a double of the double data type. And we should retain that decimal portion. Yeah, there we go, 80%. Where you'll use type conversion, it really varies, but you should be aware that you can do it, such as when using integer division. So yeah, that's type conversion in C++. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, let's get started everybody. In this video I'm going to show you how we can accept some user input in C++. We're familiar with cout followed by the insertion operator, which is 2 left angle brackets. Well, to accept some input, we would type cin for character input, followed by the extraction operator, which is 2 right angle brackets. Here's a demonstration. Let's ask a user for their name. I'll create a string variable, standard string. The name will be, well, name. Then I'll create a prompt which will ask the user what their name is. Standard output, insertion operator, what's your name? Then to accept some user input, we would type standard cin for character input, extraction operator, then where would we like to store the user input? Let's store it within our variable name. At the end of our program, let's display what the user's name is. Standard output, insertion operator, hello, name. Okay, we're gonna have one problem though. If we're using VS Code as our text editor, we need to begin using the terminal tab. Previously, we've been using output, so I can't actually type in anything to this because it's, well, for output. If you're using VS Code, this is what we'll need to do. If you're not, you can skip this step. We're going to go to File, Preferences, Settings, look up Code Runner. Then we are looking for Run in Terminal, which is right about here. Check that. Close this tab. Let's stop this from running, and we'll run it again. Okay, here we go. What's your name? I'll type in my first name, hit enter. Hello, bro, or whatever your first name was. This time, let's ask a user for what their age is. I'll store this within a variable named age. Int age. Standard output, what's your age? Standard input, extraction operator, age. Standard output, insertion operator, you are age, years old. And I think we'll need some new line characters right about here, just one. Okay, this should work. Let's try it. What's your name? I'll type in my first name, hit enter. What's your age? I'll make up an age. I like to think that I'm 21 still. Hit enter. Hello, bro, you are 21 years old. So that's how to accept some user input. You can use cin for character input, but there's just one problem though. If you type in a string that has spaces, well, once we hit a space, we stop reading that string. This time, let's ask a user to type in their full name. Okay, type in your first name and your last name. Hit enter. What's your full name? Bro code. What's your age? Hello, bro, you are 0 years old. If we need to read a string that could contain spaces, there's a function that we can use to help us with that. That is the getLine function. Standard getLine, add a set of parentheses. Within the parentheses, we will type standard cin, then comma, our variable name. Now we should be able to type in a string, including any spaces. What's your full name? Type in your own first name and last name. Hit enter. What's your age? I'll type in 21. Hello, bro code. You are 21 years old. If you need to accept a string that includes any white spaces, you're better off using the getLine function. And if you forget, I'll post this in the comments section so you can always take a look at it if you don't remember. Okay, there's just one issue with this though. I'm going to move the second question above the first. Let's take a look to see what happens. What's your age? 21. What's your full name? Hello. You are 21 years old. Here's the issue. If we accept some user input with cin followed by getLine, well, in our input buffer, there's a new line character, and we don't pick up that new line character. When we reach the getLine function, it accepts the new line character that's still within the buffer. So to prevent that from happening, there's one change that we can make to the getLine function. After cin, add this. Extraction operator, standard, WS for any white spaces. This portion will eliminate any new line characters or any white spaces before any user input. So let's try this again. What's your age? I'll type in 21. Type in your full name. And there we go. Hello, bro code. You are 21 years old. So yeah, everybody, that's how to accept some user input. Basically, you can just use cin, followed by the extraction operator. But if you need a string that could include spaces, I recommend using the getLine function. So yeah, that's how to accept some user input in C++. If you would like a copy of all this code, I'll post this in the comments section down below. And well, yeah, that's how to accept some user input in C++. Hey guys, in this video I'm going to show you 8 useful math-related functions in C++. Let's begin by creating 3 variables. Double x, and I will set this to be 3. Double y, that will be 4. Then double z, we will declare this but not yet assign it. The first useful math-related function is the max function, which will return the greater of 2 values or variables. I'll assign the result within z. Z equals standard max, parentheses, within the parentheses add 2 values or variables. I'll compare x and y. Then let's display the result. Standard output, I would like to display whatever z is. The greater number between 3 and 4 is, well, you guessed it, 4. Alternatively, there's the min function. Z equals standard min. Let's compare x, then y. So the minimum between these 2 values would be 3. So that's max and min. Now the rest of these functions are found within the CMath header file. At the top of our file, let's include CMath. We have the pow function to raise a base to a given power. Z equals pow for power. Let's raise 2 to the power of 3. Z would be 8. 2 to the power of 4 would be 16. That's the power function. Then we have square root. Z equals sqrt. What's the square root of 9? Well, the square root of 9 is 3. Then we have absolute value. Z equals abs. If you place a negative number within the absolute value function, it will give you the positive version of that number, how far it is away from 0. So negative 3, the absolute value of negative 3 would be 3. That is the absolute value function. Next, we have the round function. Let's change x to 3.14. Z equals round. Let's round x. 3.14 rounded would be 3. If you need to round up, there's a ceiling function. Z equals ceil. Ceil means ceiling. Let's round x. X rounded up is 4. Alternatively, there's the floor function, which will always round down. Let's change x to 3.99 to test it. Z equals floor x. X rounded down is 3. So yeah, everybody, that is a super quick video on a few useful math-related functions. If you head to this URL, cplus.com/reference/cmath, there's a lot more useful math functions that you may be interested in, but we just covered a few of the basics. In the next topic, we're going to create a practice program to find the hypotenuse of a right triangle. So yeah, those are a few useful math-related functions in C++. Okay, everybody, this is going to be a practice project to calculate the hypotenuse of a right triangle, which we can find with this formula. C equals the square root of a squared plus b squared. We'll begin by declaring our variables. Double A, double B, double C. Make sure you include C math as well, because we'll be using the power function as well as the square root function. At this point, we'll accept some user input for sides A and B. Standard output, we'll create a prompt. Enter side A. Standard input A. Then we'll need side B. Standard output. Enter side B. Standard input B. We can handle this formula step by step. We could reassign A equal to power function A to the power of 2. B equals power function B to the power of 2. Side C equals the square root of A plus B. Then at the end, we will display whatever side C is. Standard output side C. C. Okay, let's try this. Enter side A. I'll type in 3. Side B will be 4. Side C is 5. We could shorten this code too. We could say the square root of A to the power of 2 plus B to the power of 2. Then we no longer need these two lines. That's another way of writing it in less lines of code. Let's try this again. This time side A will be 4, side B will be 5, side C is 6.4. So yeah, everybody, that's a simple practice project, just to get us used to accepting user input, as well as some math-related functions. If you would like a copy of this program, I'll post this in the comment section down below, and well, yeah, that's a simple practice project in C++. Alright guys, we are on if statements. With an if statement, you do something if a condition you set is true. If not, then don't do it. It's as simple as that. We'll ask a user what their age is. If their age is greater than or equal to 18, they'll be allowed into our site. If they're under 18, well, we won't let them in. Let's declare variable age, int age. Then we'll create a prompt. Standard output, enter your age. Standard input age. Okay, this is how to write an if statement. You type if, then a set of parentheses, then a set of curly braces. If some condition within the parentheses is true, you perform some subset of code. We are going to check if age is greater than or equal to 18. Greater than or equal to is a comparison operator. There's other comparison operators such as less than or equals to, less than, greater than. If you need to compare if two values are equal, you use two equal signs. You don't want to say equals, because then you're setting age equal to 18. Equals is the assignment operator. So let's check to see if age is greater than or equal to 18. Then we'll print a message. Standard output. Welcome to the site. Okay, let's try this. Enter your age. Let's say that I'm 12. Well, it doesn't do anything. Since this condition evaluated to be false, we skip over this body of code. If it were true, then we execute it. This time my age is 21. I hit enter. Welcome to the site. If you would rather do something else if a condition is false, you can use an else statement. An else statement you will place at the end. There is no condition. Else, we will print standard output. You are not old enough to enter. Okay, let's try this again. Enter your age. I'll say that I'm 12. You are not old enough to enter. That's an if statement. If some condition is true, you do something. If not, you can do something else, or nothing at all. There are more conditions you can check by using an else if statement. We can check another condition by adding else if. If this condition is false, check this else if condition. Let's check to see if age is less than 0. That means somebody hasn't been born yet. You haven't been born yet. Okay, now check this out. Let's say that my age is -10. Then I hit enter. You haven't been born yet. Since this condition was false, we skip this section of code. Then we check the else if statement. Since this condition was true, we execute this body of code, then skip over the else statement. Let's add one more else if statement. Else if age is greater than or equal to 100. Standard output. You are too old to enter this site. Okay, enter your age. I am 120 years old. I hit enter. Welcome to the site. We check these conditions one by one starting from the top. We stated that our age was 120 years old. Even though we were expecting to execute this body of code, we instead executed this body of code within the if statement. That's because our age was technically still greater than or equal to 18. So the order of your if and else if statements does matter. It makes a difference. If we need to execute this body of code if somebody's age is greater than or equal to 100, well then we should probably move that to the top. Then turn it into an if statement. Else if age is greater than or equal to 18, we will display this message. Let's try this one more time. Enter your age. I am 120 years old. I hit enter. You are too old to enter this site. So yeah, that's an if statement. You do something if a condition is true. If not, then you don't do it. If you would rather do something else, you can use an else statement. If there's other conditions you would like to check before reaching the else statement, you can use an else if statement. And there's really no limit to these. If you would like a copy of this code, I'll post this in the comments section down below. And well, yeah, those are if statements in C++. Alright everybody, today we're going to discuss switches. A switch is an alternative to using many else-if statements. It compares one value against many matching cases. Here's an example of what you don't want to do. I have this program. We have variable month. Month is of the integer data type. The user will type in a number 1 through 12 to represent the month. If month is equal to 1, it is January. Else if month is equal to 2, it is February. Else if month is 3, 4, 5, so on and so forth. This is what you don't want to do because it's inefficient. It's how the game Yandere Simulator was created, if you know what that is. A better solution would be to use a switch. This is how to write one. I'm going to delete all of this. We will type switch, parentheses, curly braces. What value would we like to examine against matching cases? Let's examine our month. To write a case, we would type case, then the value. Let's check to see if month is equal to 1. So case 1, colon. On the next line, what do we want to do if month is equal to 1? Let's display a message. Standard output, it is January. At the end of this case, add break to break out of the switch. So that is case 1. Let's work on case 2. So case 2, it is February. I think the rest is self-explanatory. I'll speed up the footage. We have our 12 cases, 1 through 12, each case corresponding with a month of the year. Let's run this. Enter the month. Let's say that the month is 4 for April. It is April. One more time. The month is 12. It is December. So a switch is an alternative to using many else-if statements. It's more efficient and easier to read. If there are no matching cases, we can execute a default case. Type default. Then what would we like to do? Standard output. Let's say, please enter in only numbers 1 through 12. Enter the month. Let's type -42. Please enter in only numbers 1 through 12. So the default case is kind of like the else statement. If there are no matching cases, we execute whatever's within the default case. Let's try one more example. This time we'll have a user enter in a character, a letter grade. We'll display a custom message depending on what grade they have. Char grade. Standard output. What letter grade? Standard input grade. Then we'll create a switch. Switch, parentheses, curly braces. We're examining our letter grade against matching cases. The first case will be the character A. What will we display if somebody receives an A? Standard output. You did great. Then break. Case B. Standard output. You did good. Then break. Case C. Standard output. You did okay. Break. Case D. Standard output. You did not do good. Break. Case F. Standard output. You failed. Break. Then let's add a default case. Please only enter in a letter grade A through F. Let's try it. What letter grade? I received an A. You did great. What letter grade? F. You failed. Then let's test our default case. What letter grade? Pizza. Please only enter in a letter grade A through F. So yeah, that's a switch, everybody. It's an alternative to using many else-if statements. It's more efficient and easier to read. Your assignment is to create a switch and post it in the comments section. And well, yeah, those are switches in C++. Hey guys, in this video we're going to create a simple calculator program. Now that we know how switches work, this will be a very simple program. Let's begin by declaring our variables at the top. We'll need a character for an operator. We'll name this OP. The operator will be either addition, subtraction, multiplication, or division. Double num1, double num2, double result. This next part isn't necessary, but I'm just going to add one line of text when we begin the program. I'll add a bunch of asterisks. Let's say calculator. Then I'll add a new line to the end. Wherever my program ends, I will create another line of asterisks. And I can get rid of that new line character. Our code for our program will be within these two lines of output. Let's ask the user what operand they would like. Standard output. Enter either addition, subtraction, multiplication, or division. Standard input. We'll store the response within the variable OP. Standard output. Enter number 1. Standard input. num1. Let's copy these two lines, paste them, change 1 here and here. Now we need a switch. Switch, parentheses, curly braces. We're examining our operator against matching cases. The first case will be addition. Make sure the operand is within single quotes because it's a character. If the user wants to add two numbers, we'll take result equals num1 plus num2. Display the result. Standard output. We'll display the word result, followed by the variable result. Then I'll add a new line to the end. Then break. Then we need a case for subtraction. Case subtraction, num1 minus num2. Multiplication, case multiplication, num1 times num2. Then division, case division, num1 divided by num2. What if somebody doesn't type in a valid operator? Let's add a default case. Default, standard output. That wasn't a valid response. Then break. I'll add a new line too. Okay, we are good to go. Let's save, run this. Calculator. Let's add two numbers. Enter number 1, 1.23. Enter number 2, 3.14. The result is 4.37. Let's run this again. We will subtract two numbers. 1.23 minus 3.14 is negative 1.91. Let's multiply two numbers. 1.23 times 3.14. That's 3.8622. Now we will divide two numbers. 1.23 divided by 3.14. That is 0.39172. Let's type in an operator that's not valid. How about a W? Enter number 1, 1.23, 3.14. That wasn't a valid response. Actually, I think it would be better if we said that wasn't a valid operator. All right, everybody, that is a simple calculator program in C++ using a switch. If you would like a copy of this code, I'll post this in the comment section down below. If you're enjoying this series, please let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Okay guys, we are talking about the ternary operator, which is represented by a question mark followed by a colon. It's a replacement to using an if-else statement. You write a condition, then add a question mark, kind of like you're asking a question. Is something true? If that condition is true, we can do some code. If it's false, we do some other code. Here's an example. We have a grade. My grade is 75. If grade is greater than or equal to 60, I'll output you pass. else will output you fail. My grade is 75, therefore I pass. Another way of writing this is to use the ternary operator. First, we write a condition. So let's get rid of this if statement. After our condition, we'll add a question mark. Now, parentheses are optional. Then we write some expression. Standard output, you pass. We do this if our condition is true, colon, what will we do if that condition is false? Well, let's use whatever's within our else statement. And this would work the same. If my grade is 75, you pass. If it's 50, you fail. Let's come up with a few other examples. Let's check to see if a number is even or odd. Int number equals, what about 9? We write a condition. We'll check if number modulus 2. Remember, modulus gives you the remainder of any division. Does number divide by 2 evenly? So this returns a 1 or a 0. If number modulus 2 is equal to 1, question mark, then let's display odd. If it's false, we'll display standard output even. Okay, odd. Let's change number to 8. Now it's even. You don't necessarily need equals 1 or equals 0. The number 1 does correspond to true, and 0 corresponds to false. So you could write it like this too. 8 divides by 2 evenly, that's even. If it's 9, that is odd. Okay, last example. Let's examine a Boolean variable. Bool, how about hungry? Is somebody hungry? I'll set this to be true. Let's write our condition. Hungry equals true, question mark. Now, if you're examining to see if a Boolean variable is true, you don't necessarily need equals true. You can just say that Boolean variable. Hungry, question mark, like you're asking a question. So if hungry is true, we will do this. Standard output, you are hungry, colon, what will we do if it's false? Standard output, you are full. Hungry is set to true. You are hungry. If it were false, you are full. If we're displaying output, there's a couple different ways in which we could write this. It's up to you how you want to handle it. So another way of writing this same code would be standard output, then within a set of parentheses, then we could use our ternary operator. Hungry, question mark, you are hungry, else you are full. This would work as well. Let's just check that. Hungry is set to false. You are full. Let's set it to true. You are hungry. So yeah, that's the ternary operator, everybody. It's a question mark followed by a colon. You write a condition as if you're asking a question. If that condition is true, you do some expression. If not, you do some other expression. It's a replacement to an if-else statement. Your assignment is to post a use of the ternary operator in the comments section. And well, yeah, that's the ternary operator in C++. Hey guys, in this video I'm going to discuss the AND, OR, as well as NOT logical operators. We'll begin with AND. The AND logical operator will check to see if two conditions are true. Here's an example. We'll ask a user what the temperature is. Int, temp, short for temperature. Standard output, this will be a prompt. Enter the temperature. Standard input, temp. With the AND logical operator, we check to see if two or more conditions are true. Let's see if our temperature falls within a certain range. If condition, then a set of curly braces, we'll check to see if our temperature is above 0. If temp is above 0, and temp is less than, let's say, 30. In order for us to execute this if statement, both of these conditions must be true. This condition and this condition must be true. If one of them is false, we skip over this if statement. So if our temperature falls within that range, the temperature is good. Else, standard output, the temperature is bad. Okay, let's try it. Enter the temperature. Let's say it's 25 degrees. This will be in Celsius. The temperature is good. Let's try it again. What about negative 100 degrees Celsius? The temperature is bad. Yeah, no kidding. One more time. Positive 100 degrees Celsius. The temperature is bad. So with the AND logical operator, we check to see if two or more conditions are true. There's another way of writing the same program too. We can use the OR logical operator, which is represented by two vertical bars. It checks to see if at least one of two conditions are true. If temp is less than or equal to 0, or temp is greater than or equal to 30, the temperature is bad, else the temperature is good. In order for us to execute this if statement, only one condition has to be true. If both of them are false, we don't do anything. What's the temperature? The temperature is 25. That's within that range. The temperature is good. One more time. Enter the temperature. It is negative 100 degrees Celsius. The temperature is bad. All right, so that's the AND as well as the OR logical operator. There's one more, the NOT logical operator, which is an exclamation point. It reverses the logical state of its operand, meaning if a condition is true, it becomes false. If it's originally false, it becomes true. Let's create another variable. This will be a Boolean sunny. Sunny can be true or false. I'll write another if statement. If sunny is equal to true. Now, if you're examining to see if a Boolean variable is true, you don't necessarily need to say equals true. You could just type the name of the Boolean variable. If sunny. If sunny is true, we'll display a message. Standard output. It is sunny outside. Else, standard output. It is cloudy outside. Okay, one more time. Enter the temperature. It's 20 degrees Celsius. I should probably add some new line characters. There. Enter the temperature. It's 25 degrees Celsius. The temperature is good. It is sunny outside. If we use the NOT logical operator, we can precede a condition with an exclamation point. We're checking to see if it's not sunny. That means we would want to change our output. It is cloudy outside, else it is sunny outside. Let's change sunny to be false. Enter the temperature. It is 50 degrees Celsius. The temperature is bad. It is cloudy outside. So yeah, everybody, those are logical operators, and, or, not. Your assignment is to use either the AND, or otherwise not logical operator. Then post it in the comment section down below, whatever you wrote. So yeah, those are logical operators in C++. Okay guys, in this video we're going to create a temperature conversion program to convert from Fahrenheit to Celsius or Celsius to Fahrenheit. At the top of our program, let's declare our variables. Double temp. Temp is short for temperature, then char unit. Will the user select Celsius or Fahrenheit? Now with my programs, I like to add a title at the beginning. Standard output. Temperature conversion. It's totally not necessary, but it's something that I like to do. Then I'll add another line of output at the end of my program to show the user that the program is over. I'll just add a bunch of asterisks. Like I said, totally not necessary, but it's something I just like to do. I will display a couple lines of output. F equals Fahrenheit. I can never spell Fahrenheit right. I think that's okay. I'll add a new line. Standard output. C equals Celsius. Add a new line. Standard output. What unit would you like to convert to? Standard input unit. The user will hopefully type in F or C, depending on what they want to convert to. Let's check to see if the user types in F first. If unit is equal to the character F, that's a capital F, but maybe the user types in lowercase f, I'll add an or conditional operator. Or unit is equal to a lowercase f. That's also a valid response. If the user would like to convert a temperature to Fahrenheit, these are the steps we can do. Standard output. Enter the temperature in Celsius. Standard input temp to store the temperature. To convert our temperature from Celsius to Fahrenheit, we can assign temp equal to, now here's the formula, 1.8 times our temp plus 32. Then we will display the temperature. Standard output, temperature is temp degrees Fahrenheit. Then I'll add a new line. If the user would like to convert to Celsius, I'll add an else if statement. Else if unit is equal to the character capital C, or unit is equal to the character lowercase c. We can copy these two lines of code and reuse them. We'll just repurpose them. Enter the temperature in Fahrenheit. Here's the formula to convert from Fahrenheit to Celsius. Temp equals our current temperature minus 32 divided by 1.8. Then let's display our temperature. I'll copy this line of code, paste it, change Fahrenheit to Celsius. Now what if the user doesn't type in a valid response? Else, standard output, please enter in only C or F. Add a new line. And that should be everything. Let's try this. Temperature conversion program. What unit would you like to convert to? I would like to convert to Fahrenheit. Enter the temperature in Celsius. So what's 0 degrees Celsius converted to Fahrenheit? That is 32 degrees Fahrenheit. Let's go again. Let's convert to Celsius. Enter the temperature in Fahrenheit. What's 100 degrees in Celsius? 37.7 degrees Celsius. Let's type in a response that's not valid. I would like to convert to pizza. Please enter in only C or F. All right, everybody, that is a program to convert from Fahrenheit to Celsius or vice versa. I thought we could use some practice using conditional operators, as well as if statements. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a temperature conversion program in C++. Hey, what's going on, everybody? So in this video, I'm going to explain some useful string methods that you might be interested in. Let's begin by creating a variable named name. Standard string name. We'll accept some user input. We'll need a prompt. Standard output. Enter your name. A user's name may contain spaces. we're better off using the getLine function. Standard getLine, standard cin, name. The first useful method is the length method. Type your string, name, follow it with dot, length, parentheses. The length method will give you the length of a string. Let's write this within an if statement. If name.length method is greater than 12, we'll print a message, such as your name can't be over 12 characters long. Standard output, your name can't be over 12 characters. Else we'll print a different message. Standard output, welcome the user's name. Enter your name, type in your full name. Welcome whatever your name is. Okay, now what if our name is over 12 characters? Type in your full name, then just add a bunch of characters. Your name can't be over 12 characters. That is the built-in length method of strings. You type a string, follow it with dot, length, parentheses. Wherever you invoke this method, in that spot you will return the length of that string in characters. The empty method will return if a string is empty or not. Type your string, name, dot, empty, parentheses. This returns a Boolean value. If name is empty, we'll display a message. You didn't enter your name. Else, hello, whatever your name is. Okay, I'm just going to hit enter. You didn't enter your name, but if I do enter my name, it works normally. Hello, whatever your name is. That is the empty method of strings. You'll check to see if a string is empty or not. A useful case of this is to check to see if somebody enters in some user input. Another is clear, name.clear. Then let's display our name. Standard output, hello, name. Enter your name, type in your first name and last name. Hello, and we don't have a name anymore because that name has been cleared. So that is the clear method. We can append a string to another string. After my name, I will use append, parentheses. Within the parentheses, we can add a string to the end of another string. I'll add @gmail.com. Standard output, your username is now name. Enter your name. Your username is your name with @gmail.com appended to it. That is the append method. We can return a character at a given position within a string. Standard output, type your string, name, dot, @ parentheses. So the first character in a string has an index of 0. I'll display whatever that character is. Enter your name. So the first character in my string is a capital B. The character at index 1, well, that would be R. We can insert a character at a given position. Type your string, follow it with insert. There will be 2 arguments we'll list within the parentheses. An index, so the beginning of our string would have an index of 0, comma, then what would we like to insert? I'll insert the @ sign at the beginning of my name. Then let's display our name. Okay, so we now have the @ sign inserted at the beginning of our string. Or you could pick a different position. The index of 1 would be the second character technically. So yeah, pick a position, then you can insert a string. Now we can find a certain character. I would like to find if there's any spaces within my name. Name.find then place a character. I'll look for any white spaces. This method will give me the position of the first space. Type in your first name and last name. The index of the first white space within my name has an index of 3. The first character is always 0, 0, 1, 2, 3. Okay, then lastly, erase. Name dot erase. We can erase a portion of a string. We'll need a beginning index and an ending index. I'll eliminate the first 3 characters. Then we will display our name. Enter your name. Okay, and that's what's left of my name. I deleted the first 3 characters. The first number is the beginning index. The second is the ending index. It's not inclusive though. So yeah, those are a few helpful string methods. If you would like to know more, head to the string class on the C++.com website. And there's a fairly extensive list. Hey, if you're enjoying the series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to explain while loops. A while loop is much like an if statement, except we can repeat some code potentially an infinite amount of times. Here's an example of where a while loop would be useful. Let's say that we'll have a user enter in their name. Standard, string, name. At first, I'll use an if statement. If name, I'll check to see if the name is empty. Did the user actually type in something? If name is empty, we'll create a prompt. Standard, output, enter your name. Standard, getLine, standard, input, name. Once we exit the if statement, we'll display a message involving the user's name. Standard, output, hello, name. Enter your name. I'm just going to hit enter and not enter in anything. Hello, and I don't have a name. What if we need to force the user to do something in order to continue with the rest of the program? Well, we could change this if statement to a while loop. If this condition remains true, we will execute this code a potentially infinite amount of times. Once we reach the end of this code block, we check the condition again. If it's still true, we repeat the code again. Enter your name. I'm going to hit enter. Enter your name. No. Enter your name. No. Enter your name. No. So I can't actually continue with the rest of my program until I type in something. I'll type in my full name, hit enter. Hello, whatever your name is. Basically speaking, a while loop is kind of like an if statement, except it can repeat some code infinitely, as long as this condition remains true. We check this condition once when we enter the while loop, then anytime we finish the while loop, we check the condition again. If the condition is false, we exit, then continue on with the rest of the program. You do want some way to exit the while loop. Let's write a condition that we won't be able to change at all. While 1 is equal to 1. There's no way we can escape this while loop. So this is what's known as an infinite loop. I'll display a message. Help. I'm stuck in an infinite loop. Then when I run this, yeah, we're stuck in an infinite loop and we can't actually move on or do anything. So yeah, that's basically a while loop, everybody. While some condition that you set remains true, you will continue to execute some code. A great use of a while loop is that you can force a user to do something in order to continue with the rest of the code. Your assignment is to use a while loop, then post it in the comments section down below. And well, yeah, those are while loops in C++. Alright everybody, do while loops. A do while loop, it does some block of code first, and then you repeat that block of code if a condition is true. Here's an example. Let's write a program that will ask a user to enter in a positive number. First, we'll use a while loop. That'll demonstrate how a do while loop would actually be better for the situation. We have an integer number, int number. I'll write a while loop. While number is less than 0, we will prompt the user to enter in a positive number. Enter a positive number. Okay, standard, input, number. Outside of the while loop, at the end of our program, let's display the number. Standard output, the number is number. So this isn't going to work normally. Here's why. Let's run this. The number is 0. So this is what's going on. We've declared our number, but have not assigned a value quite yet. When we reach the while loop, we check the condition. If the condition is true, we execute this block of code. Since we've declared an integer variable, but have not assigned it a value, it's defaulting to just 0. 0 is not less than 0, so this condition is false. That means we skip the while loop and continue on. Another way in which we could write this, but it's not the best solution, is that we could copy what's within this block of code, then run it once. If number is still less than 0, we would then execute this block of code repeatedly. Let's try this again. Okay, enter a positive number, 1, 2, 3. The number is 1, 2, 3. Let's type in a negative number, -1. Enter a positive number, -1. Enter a positive number, -1. So I can't actually continue until I enter in a positive number. You know, this does work, but there's a much better way of writing this because, you know, we're repeating at least 2 lines of code when we really don't need to. We need to run this block of code once and then repeat it if this condition is true. Well, you know what would be great for that? A do-while loop. Let's eliminate these 2 lines of code. To create a do-while loop, we will move this condition to the end. While, then our condition, preceding the left curly brace, right, do. Do this code once, and then check the condition. Make sure you have a semicolon at the end. Let's try it again. Enter a positive number. I'm just going to type in a negative number. -1, nope. -1, nope. How about a positive number? 1, 2, 3. The number is 1, 2, 3. So that's a do-while loop. You do some block of code first, then you repeat it again if the condition is true. It's an optional way to repeat some code. One good use of a do-while loop that comes to mind, maybe we're playing a game. We would like to run the game once. At the end of the game, a user can choose if they would like to play again. Based on the user's input, if they would like to play again, we can run the game one more time, repeatedly. So that's a do-while loop, everybody. I'll post this code in the comments section down below. And well, yeah, that's a do-while loop in C++. Alright guys, in this video I'm going to explain for loops. A for loop is a loop that will execute a block of code a specified amount of times. To create a for loop, we type for, parentheses, curly braces. Within the for loop, there are up to 3 statements that we can add. The first is that we can create an index, a sort of counter. Int, index. I'll set this equal to be, we'll start at 1. Then finish the statement with a semicolon. Now, what a lot of people do, instead of saying index, they'll just shorten this to I. The second statement is a stopping condition. Let's count up to 3. I'll continue this as long as I is less than or equal to 3. Then semicolon to finish that statement. The third statement is that we can increment or decrement our counter, our index. I'll increment my index by 1 by saying I++. Okay, let's repeat something 3 times. Standard output. How about Happy New Year? Happy New Year. This code should be repeated 3 times. Happy New Year, Happy New Year, Happy New Year. I should probably add a new line. Now let's try this 5 times. We'll begin I at 1. We'll continue this as long as I is less than or equal to 5. Okay. 1, 2, 3, 4, 5. And that's it. This time, let's count up to 10, then display Happy New Year once we exit out of the for loop. I'll move this line to outside of the for loop. I'll set I to be 1. We'll continue this as long as I is less than or equal to 10. During each iteration of the for loop, I will display whatever I is. Standard output I, then I'll add a new line. Okay. Here we go. We're starting at 1, then we're counting up to 10, then we escape the for loop. Once we escape the for loop, then we print Happy New Year. When you increment or decrement your counter, you can skip iterations. Let's increase I by 2 after each iteration. I plus equals 2. Now we're counting up by 2s. 1, 3, 5, 7, 9. Happy New Year. We can even set our index to be a different number. Let's begin at 0. We're still counting up by 2s. 0, 2, 4, 6, 8. Happy New Year. We could even increment I by 3. 0, 3, 6, 9. Happy New Year. Or we could decrement and go backwards. I minus minus. This time we will begin at 10, then continue as long as I is less than or equal to 0. So this would be a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Happy New Year. Okay, let's decrement I by 2 after each iteration. I minus equals 2. 10, 8, 6, 4, 2, 0. Happy New Year. So yeah, everybody, that's a for loop. There's a lot of overlap where you could use either a while loop or a for loop. For loops tend to be better in situations where you only need to repeat code a certain amount of times. Your assignment is to post a use of the for loop in the comment section down below. And well, yeah, those are for loops in C++. Hey everybody, so in this video I'm going to explain the break and the continue keywords. The break keyword will break out of a loop. Another place where you see this is a switch within a switch statement. Continue will skip the current iteration. Here's an example. Let's create a for loop that will count up to the number 20. I'll set I equal to be 1. I will continue this as long as I is less than or equal to 20. Then increment I by 1. Standard output, I'll display whatever I is. Then I'll add a new line. New line. Then let's take a look. So we have the numbers 1 through 20. I would like to skip the number 13 because 13 is considered an unlucky number. I know it's a weird example. What I'll do is use an if statement within my for loop. If I is equal to 13, first we'll break, then see what happens. If we break where I equals 13, then we have the numbers 1 through 12. Once we hit 13, we break out of the loop. We do not finish the rest of the iterations. If we replace break with continue, this is instead what happens. We have the numbers 1 through 20, but the number 13 isn't there. So using the continue keyword, we skip the current iteration. So yeah, that's the break and the continue keywords. These keywords are available if you need them, but where you'll use them, it really depends. But just so you know, they exist. And that is the break and the continue keywords in C++. Alright guys, we are on nested loops. A nested loop is just a loop that's inside of another loop. It doesn't matter what kind of loop you're working with, it can be a while loop or a for loop or whatever. Here's an example. We'll create a loop to count the numbers 1 through 10. We'll count to 10 3 times. So let's create a basic loop for now. Int I, I'll set this equal to be 1. The condition will be I is less than or equal to 10. Then I will increment I by 1. During each iteration, I will display whatever I is. Then I'll add a space. There. This loop will count up to 10. Just like that. So now I would like to count up to 10 3 times. Well, I can stick this loop in another loop. So let's create the outer loop. For int I, I'll set this equal to be 1. I'll continue this as long as I is less than or equal to 3. Then increment I by 1. So I'm going to take this loop and stick it within the curly braces of the outer for loop. However, you don't want these loops to have the same index. A common naming convention for the inner loop is to use j as the counting index. J, 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 j. Okay, let's take a look. Okay, now we count up to 10 3 times. But what I think I'm going to do is that every time we exit the for loop, the inner for loop, I'll just print a new line character. Standard output, new line. Yeah, that's much better. So yeah, nested loop is just a loop inside of another loop. Just as a practice project, let's create a program that will print a rectangle made out of symbols. We'll let a user specify how many rows and columns. we'll use our nested loop that we created previously. So we have int rows, int columns, then char symbol. We're going to ask for some user input. We'll need some prompts. Standard output, how many rows? Standard input, rows. Let's copy this, paste it, change rows to columns, then enter a symbol to use. Standard input, symbol. We'll continue printing rows as long as I is less than or equal to rows, whatever we typed in. We don't want any more rows than what the user wants. The inner loop is going to be in charge of the columns. J is less than or equal to columns. In place of printing J, let's print our symbol, whatever the user picked. And we do not need to separate these with any spaces. All right, let's try this. How many rows? What about 3 rows? Then 6 columns. Enter a symbol to use. What about the @ sign? And there's our rectangle. There's 3 rows and 6 columns. Let's try it one last time. How about 4 rows and 5 columns? I'll use a $sign. Okay, we have 4 rows, 1, 2, 3, 4. 5 columns, 1, 2, 3, 4, 5. So yeah, everybody, that's a nested loop. It's a loop that's inside of another loop. When you'll use these, it really depends on the situation. I thought this would be a fun practice project. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are nested loops in C++. Hey, this is Bro from the future. Before you begin this topic, to work with random numbers, you may need to include this header file, ctime. Hey everybody, in this video I'm going to show you how we can generate some random numbers. Just so you know, these are pseudo-random numbers. They're not truly random, but they're close. Maybe if you need to roll a 6-sided dice for a game, well then this would work perfect. To generate some random numbers, we'll need to initialize the random number generator by typing srand, add a set of parentheses, semicolon. Within the srand function, we'll need a seed. What programmers typically do is that they'll use the current calendar time as a seed. Within the parentheses, type time, parentheses again, then pass in null. I'll store the first random number within a variable. Int num equals, to generate a random number, we invoke the rand function. Then I'll display this. Let's take a look to see what we have. Standard output num. Okay, the random number that we have is 3,231. Using the rand function, this will generate a random number between 0 and 32,767, but we don't necessarily need a number that large. I just need to roll a 6-sided dice. Well, what we're going to do is follow this with modulus, then the range of numbers we would like. If I'm rolling a 6-sided dice, I'll type modulus 6. Modulus gives you the remainder of any division. So take whatever number we roll, divide it by 6, take the remainder, and that's our number. But there's one issue with this. We have 5, 2, and 0. Technically, the range of numbers is currently 0 through 5. If we need 1 through 6, what we can do is add 1. Plus 1. This should give us a random number between 1 and 6. There it is, 6. So I tend to play a lot of Dungeons & Dragons. There's polyhedral dice. One die that we commonly roll is a 20-sided dice. So if I would need a random number between 1 and 20, I would say rand function modulus 20. My random number is 1. Wow, that's surprisingly low. Then I have a 14. Maybe you need a random number between 1 and 100. Rand function modulus 100. My random number between 1 and 100 is 67. Now I need to roll 3 6-sided dice. I'm going to create 3 variables. Let's name this num1, rand function modulus 6 plus 1. Then let's copy this, paste it twice. We have num1, num2, num3. Let's display num1. I'll add a new line. Then do this 2 more times for num2 and num3. So our 3 dice that we're rolling are 5, 2, 2. Then again, 3, 1, 4. Yeah, everybody, that's how to generate some pseudo-random numbers. They're not truly random, but they're close. If you have a simple game you're working on, this would work perfect. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to generate some random numbers in C++. Hey everybody, in this topic, we're going to create a random event generator using random numbers and a switch. This might be useful maybe if you're writing a game. You need some random event to occur, like random monsters show up, or the weather changes, anything like that. We'll be working with random numbers. You may need to include this header file, include C time, because we need access to the time function. To work with random numbers, we'll need to generate a seed. srand function, pass in time, pass in 0. This function will use the current time as a seed to generate random numbers. We'll create a local variable to store our random number, int randnum equals, use the rand function, modulus, then what's the range of numbers you would like? I would like the numbers 1 through 5. But this will give us 0 through 4, so I'm going to add 1 to the end. My integer random num will be a random number between 1 and 5. I'm going to create a switch to examine this random number against many matching cases. So we have case 1 through 5. If the random number is 1, what would you like to do exactly? So in this program, I think we're going to give away prizes, like it's a random prize generator. Depending on the random number, we'll give a participant a random prize. Standard output, you win. How about a bumper sticker? A bumper sticker. That will be the lowest tier prize. Then we should probably add a break to break out of the switch. Okay, let's think of some others. I should probably break after these. Prize 2 will be a t-shirt. Prize 3, how about a free lunch? Prize 4, maybe a gift card. Case 5, concert tickets. That sounds good. So when I run this program, we'll generate a random number between 1 and 5. Depending on what that number is, we'll execute the code found within one of these cases. Let's see what I won. I won a free lunch. If I try this again, there's a good chance it'll be a different prize. This time I won a bumper sticker. I won a bumper sticker again. Come on, I want those concert tickets. I'll take a gift card. That's not bad. Now, if you don't add these break statements, you'll just fall through the switch. You won a gift card, you won concert tickets. So if you only want somebody to win one prize, you'll want to exit out of the switch by including this break statement. So yeah, everybody, I thought that might be an interesting program. You can generate some random event. Maybe it's for a game or something. I thought maybe a random prize giveaway would kind of be interesting. This program is more or less for practice. Your assignment is to write a switch with some random events, then post it in the comment section down below. And well, yeah, that's a random event generator using C++. Alright, welcome back everybody. In this video, we're going to create a simple number guessing game. Let's declare our variables. Int num, our number will be randomly generated. Int guess, this variable will hold the current player guess. Int tries, how many tries is it going to take for the user to guess the correct number? We'll be using the srand function to generate some random numbers. Pass in time, pass in null. We will assign our variable num a random number between 1 and 100. Rand function, modulus 100, then add 1. This function will give us a random number between 1 and 100, store it within num. Just for some decorations, I'm going to create a title for this game. Number guessing game. Then add a new line. I'll place all of this code within a do while loop. Do while our guess does not equal num. We will have the user type in another guess. We'll create a prompt, standard output, enter a guess between 1 through 100. Standard input, guess. Once the user types in a guess, we will increment our tries variable by 1 to keep track of the score. Now we'll have to examine the guess versus the number. If guess is greater than num, let's display too high. I'll add a new line. Else if guess is less than num, then we'll display too low. Else, if the guess is not above the number and the guess is not below the number, the guess must be equal to the number. Standard output, correct. We'll display the number of tries. We'll display our tries variable. I'll add a new line. And I'll just add a line of text for decoration at the bottom once we exit the game. That should be everything. Let's run this. Number guessing game. I'll guess something right in the middle. 50. Too low. Okay, so the number is between 50 and 100. I'll guess right in the middle of that range, 75. Too high. Something between 50 and 75. Perhaps 62. That's still too high. 56. Too high. 53. Too low. 54. 55. All right, the correct guess was 55. It took me 7 tries. I don't really think that's too good, but it works. Okay, everybody, that is a simple number guessing game involving the use of do-while loops and generating random numbers. If you would like a copy of this code, I'll post this in the comments section down below. If you're enjoying this series, please let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, everybody, we have a pretty important lesson today. Today, we're going to talk about functions. A function is a block of reusable code. If you ever think that you're going to use some section of code more than once, you might as well stick it within a function. Here's an example. I'll create a function to sing happy birthday. Currently, our program is within the main function. To begin the program, we call the main function. Before the main function, we can create a new function. For the time being, we're going to type void, then a unique function name. The function name should be descriptive of what it does. If I'm going to sing happy birthday, let's name this function the happy birthday function. Then add a set of parentheses, then a set of curly braces. You can see that this is almost identical to our main function, except with the main function we have a return type and return 0. What would we like to do when we invoke this function? Let's sing some of the lyrics to happy birthday. Standard output. Happy birthday to you. I'll add a new line. I'll repeat this a couple times. Happy birthday, dear you. Happy birthday to you. To invoke this function, all we have to do is within the main function, type the function name, followed by a set of parentheses. This will call, or otherwise known as invoke the function. I like to think of the parentheses as a pair of telephones that are talking to each other. To use a function, you have to call the function, call it up on the phone. So when I run this code, we have the lyrics to Happy Birthday. This function is reusable. I can call this function as many times as I want. I'll call this function 2 additional times. Just to separate these lyrics, I'm going to add an additional new line character. Okay, we now should have 3 verses of Happy Birthday. 1, 2, 3. That's because I called the function, well, 3 times. A function is just a block of reusable code. Now, what a lot of people do is that they'll declare and define their functions after the main function because it's more readable to many people. But there's one issue with this. Happy Birthday was not declared in this scope. Our programs are read from the top down. Since we're invoking the Happy Birthday function before we even know what it is, well, the compiler doesn't recognize it. A solution to this is that before the main function, you can declare functions, but define them later. Let's declare Happy Birthday before the main function. Then make sure you add void, or a return type. So void Happy Birthday. We can now use this function even though it's after the main function. A lot of people like to define their functions after the main function. It's another way in which you can write it. Just be sure to at least declare them before the main function. Now check this out. What if we have a variable? Standard string name. Assign this whatever your name is. I'm going to use this name that's declared in the main function and use it within the Happy Birthday function. Let's replace you with the user's name. Happy birthday to name. I'll add a new line. Then I'll copy this, paste it, and let's change this line as well. All right, now when I run this, here's the issue. Name was not declared in this scope. Think of each function as a house. The main function is your house. Functions outside of the main function would be your neighbors, their house. Functions can't see what's going on inside of other functions. You can't see what's going on inside of your neighbor's house. You're only familiar with what's going on inside of your own house. In order for the Happy Birthday function to use the main function's name variable, it needs to be made aware of it. To do that, when you invoke a neighboring function, you can pass that variable or some other value as an argument. So within the parentheses when you invoke that function, place your values or variables. I would like to make my Happy Birthday function aware of this name variable within the main function. When you send some data over to a function, that data is also known as an argument. However, the receiving function needs a matching set of what are called parameters. If this function is going to receive this data, this name, you need a matching parameter. To set up a parameter, you first list the data type. We will receive a standard string, then we can list a parameter name. Let's say name. Now this Happy Birthday function can use this name variable within the main function. If you have a function declaration at the top of your program, you'll have to add that parameter there as well. So Happy Birthday, standard string, and we can run this. Happy birthday to whatever your name is. Functions aren't aware of what's going on inside of other functions, but you can make them aware of any local variables or values by passing them as an argument, but you'll need a matching set of parameters. The name or otherwise unique identifier of your parameter doesn't necessarily need to have the same name, so to say. You can name it something else. Instead of naming our parameter name, let's say birthday boy or birthday girl. Happy birthday to birthday boy. And that should work the same. So you can rename parameters, but let's revert that back. Now let's pass an age. Int age equals make up some age. I would like to send my age over to the Happy Birthday function, so I will pass that as an additional argument. Separate each argument with a comma. We'll send our name as well as age. Now we need a matching set of parameters. Right now, the Happy Birthday function is only equipped to receive a name. So we list the data type, int age, and if you have a function declaration, change that there as well. Then I'll add one more line. you are age years old. Then this should work. Okay, happy birthday to whatever your name is. You are whatever your age is, years old. So that's a function, everybody. It's a block of reusable code. If you think you're going to perform some code more than once, you can stick it within a function. Whenever you need it, you just simply call it. If you need to make your function aware of any variables, you can send them as arguments to that function, but you'll need a matching set of parameters in the function definition and the declaration. So yeah, those are functions, everybody. Your assignment is to create a unique function and post it in the comments section. And well, yeah, those are functions in C++. All right, everybody, we are on the return keyword. The return keyword will return a value back to the spot where you called the encompassing function. The return keyword is commonly found at the end of a function, much like the main function. When we invoke a function, we can return some value back. Here's an example. I'll create a function that will calculate the area of a square, but we'll need to pass in a length, the length of one side. This will be a double length, assign some value, 5.0 is good. Then we'll need to declare and define a function. At the top of my program, I'll add a function declaration. For the time being, we'll write void, but that will change soon. Void, I'll name this function square. We will square a length. List any parameters, we will accept a double value, which we will name length. Then I'll need a function definition. I'll add that after the main function, void square. I'm going to create a temporary variable named result. It will be of the double data type. We will take length times length to calculate the area. Then I will use that return keyword. Return. What are we returning? We're returning our result. If we're returning a value, we need to change this keyword void to match the data type of what we're returning. We're returning a double, so I will change void to double. And then make sure you change that within the function declaration as well. Double square. You could do this in one line of code. You don't necessarily need to. We could simply just return length times length. That is also valid. And that's probably how I would write it. We now have this function that will calculate the area of a square once we pass in a length. I'm going to create a new variable called area. It will be of the double data type, and I will set this equal to. Then let's invoke the square function. Pass in our length variable as an argument. At this point of the program, area should be assigned a value. Let's display it. Standard output area. I'll add my area variable, then add centimeters squared, then new line. The area of our square is 25 centimeters squared, and I could change this to a different number, like 6. The area is now 36 centimeters squared. Let's create another function. This function will find the volume of a cube if we know the length of a side. We'll return a value of the double data type, but I will name this cube. We will still accept a length of the double data type. Let's copy this, paste it, change square to cube, return length times length times length. Double volume equals, we'll invoke our cube function, pass in our length, then I will display whatever the volume is. Volume, my volume variable, centimeters cubed. If the side of a square is 6 centimeters, the area would be 36. If it was a cube, the volume would be 216 centimeters. If you need to return a value back to the spot in which you invoked a function, be sure to list the data type of what you're returning. Let's try another example involving strings. I'll create a function that will add a user's first name, their last name, and create a new string called full name. Let's declare our variables. Standard string first name equals add your first name. Standard string last name equals add your last name. Then I'll create a function to concatenate two strings together. We're returning a string. I will list the data type as standard string. I'll name this function concat strings. We will have two arguments, two standard strings. Standard string. I'll name the first string string1. Standard string. String, I misspelled string, string2. So we have our function declaration. Now we just need to define it. I'm going to return string1 plus, I'll add a space between the first name and the last name, plus string2. I'll create a third variable, standard string, full name equals, I will invoke my concat strings function. Then I need to pass in two strings as arguments. I'll pass in my first name and my last name. Then let's display the full name. Standard output, hello, the user's full name. Hello, bro code, or whatever your first and last name is. So yeah, everybody, that is the return keyword. Wherever you invoke a function, you can return a value back to that spot in which you invoked that function. If you're returning a value, just be sure that you change the return type of that function to match the data type of the value being returned. In this example, I returned a string, a standard string. So the return type of this function would be a standard string. So that's the return keyword, everybody. Your assignment is in the comment section to post a function that returns some value. So yeah, that is the return keyword in C++. Hey guys, in this topic, I'm going to explain overloaded functions. In C++, and actually with many other programming languages, you can have different versions of the same function. Here's what I mean. I have a function to bake a pizza because, well, I like pizza. Bake pizza. This function will have no parameters. All I'm going to do within this function is display the words, "Here is your pizza." Then I'll add a new line. Then I should probably add a declaration at the top. Void bake pizza. Then to invoke this function, I would type the function name. Here is your pizza. This time, I would like to bake a pizza that has toppings. Right now, we just have a plain pizza with no toppings, and that's kind of lame. I'm going to create an additional version of this bake pizza method, but it's going to have different parameters. Void bake pizza. We will accept a string. Standard string. I'll name this string topping1. We'll accept one topping as an argument. Standard output, here is your, I'll add my topping here, topping1, pizza. Then be sure to add your function declaration too. Bake pizza, then this time we are accepting a string. It is valid for functions to share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function signature. I can bake a pizza that has no toppings. Here is your pizza. Or I could pass in a topping, like pepperoni. Here is your pepperoni pizza. Let's create an additional function that accepts two toppings. So we have topping1, topping2. Here is your topping1 and topping2 pizza. Then add your function declaration. Topping1, topping2. Now I can bake a pizza that has two toppings. I would like pepperoni and mushrooms. Here is your pepperoni and mushroom pizza. So yeah, everybody, those are overloaded functions. Functions can share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function's signature, and each function signature needs to be unique, kind of like an ID. So yeah, those are overloaded functions. If you would like a copy of this code, I'll post this in the comments section down below, and well, yeah, those are overloaded functions in C++. Okay, everybody, we gotta discuss variable scope. I'll explain local variables and global variables. Local variables are declared inside of a function or block of curly braces, such as within the main function or inside of another function. Global variables are declared outside of all functions. You tend to see them at the top of your program. There are some major differences between the two. Let's begin with local variables. Suppose I have some number, int my_num equals 1. If I need to display my_num, I can use standard output my_num. And of course, this will display my_num, which is 1. Now what if I have a function to display my_num? Void print num. Let's move this line of code to our print num function. I'll need to add a function declaration to the top of my program. Then we will invoke this function, print num. Okay, this isn't going to work, and here's why. My_num was not declared in this scope. Functions can't see inside of other functions. My function print num has no idea what this my_num variable is. My_num is a local variable to the main function. That's why we pass arguments to functions. We'll make the function aware of this value, but you'll need a matching set of parameters. Int my_num, then add that to the function declaration, int my_num. And this would work. That displays the number 1. But let's get rid of these parameters. It is legal to reuse the same variable name, as long as it's within a different scope. Within the printNum function, I'll also have a my_num variable that has the same name, but I'll give this a different value. When printing my_num, it prints 2. We have 2 versions of the same variable, and this is fine because they're within different scopes. Now, a global variable is declared outside of all functions. You see these at the top of your program. I will declare int my_num equals 3. I'm going to delete these 2 local variables. If I was to invoke the printNum function and print my_num, well then, that number is 3. This global variable is also available within the main function, so I will print my_num here as well within the main function. So we have 3 and 3. It's best to avoid global variables if you can, because it pollutes the global namespace. Also, variables declared within a function are much more secure, because like I said, functions can't see inside of other functions. If we had both local and global variables, my_num within the main function will be 1. Within the printNum function, it will be 2. If I was to display my_num for both of these, I'm going to add a new line to each of these. New line, and new line. A function will use any local variables first, before resorting to any global variables. That's why our printNum function prints 2, and the main function prints 1. If you'd rather use the global version, you can use the scope resolution operator. So precede your variable name with 2 colons. That is the scope resolution operator. I'll do that here as well. In place of using the local version of my_num, we will use the global version. And we will print 3. We're using the global version of my_num instead of the local version. So yeah, that's variable scope. Local variables are declared inside of a function, or anytime you see a set of curly braces. A variable declared inside a set of curly braces is hidden to the outside world. A global variable is declared outside of all functions, and is accessible to all functions within the program. Like I said, you should try and avoid using global variables if you can, because it pollutes the global namespace, and these variables are less secure. So yeah, that's variable scope. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this topic we're going to create a banking program for practice. We'll be able to deposit money, withdraw money, and show a balance. This is more or less just for practice. Let's begin by creating our functions. Void show balance. There will be one parameter, double balance. Whatever our bank account balance is, we'll show it. The return type is double. Deposit. No parameters. Double withdraw. And there will be one parameter. Double balance. Let's fill in a few things within the main function. Double balance, and I will go ahead and set this to 0, as well as int choice. I will set that to 0 as well. We'll use a switch to determine if the user wants to show their balance, make a deposit, a withdrawal, or exit. Let's display some output, some prompts. Standard output, enter your choice. And I'm just going to add some text decorations because I think that'll be cool. Maybe a bunch of asterisks. And one more. Okay, we have option 1. 1, show balance. 2 will be deposit money. 3 is withdraw money. 4 will be exit. Then we'll accept some user input. Standard, input, choice. Now we're going to create a switch. We're examining the user's choice. Switch. We're examining our choice against many matching cases. We have case 1, case 2, 3, 4, then a default case. Okay, case 1. The user wants to show their balance. We'll invoke the show balance function, but we need to pass in our balance. Balance. And then we are going to break. Case 2, the user wants to deposit money. So we're going to take our balance equals balance plus our deposit function. So deposit will return a double right here. So we're going to add that to our balance once we verify it. Actually, we can shorten this to balance plus equals whatever value is returned with the deposit function. Then we are going to break. Case 3, withdraw money. Balance minus equals the withdraw function, pass in our balance. We're withdrawing money from our balance once we verify it. Then we're going to break. We'll exit with case 4. I'll display some output. Standard output. Thanks for visiting. Then I'm going to break. Okay, default case. Standard output. Invalid choice. Okay, now we're going to place all of this code within a do-while loop. Do all of this while some condition is true. So let's take all of this code, cut it, put it within that do-while loop. Let me just format this a little bit. The condition will be while choice does not equal 4. 4 is what we use to exit. We'll need to add some function definitions, but I'm going to fill these in later. We'll need to return something, so let's return 0 for the time being. For 2 of these functions at least. Return 0. Okay, let's run and compile this just to test our do-while loop. Okay, enter your choice. 1, show balance. That doesn't show our balance yet, but it will. Deposit money, withdraw. Now we should be able to exit by pressing 4. Thanks for visiting. Okay, so we know that the do-while loop is working. Let's fill in our functions. Let's begin with show balance. Now with the show balance function, we're receiving our balance as an argument. So I'm going to display standard output your balance is $, or some other currency if you choose. I'll display our balance, then add a new line. So let's say we have $123 in our account. I'm going to show my balance. $123 even. But I would like to display cents. I'll need 2 decimal places after the decimal. So there's one thing we can include. We'll include this header file. Include IO man IP. There's a function in here to set some precision for floating point numbers. I'm going to make this change after the $. Standard set precision, pass in 2 for 2 decimal places, then add standard fixed. This will display our balance up to 2 decimal places after the decimal point. So let's try that again. Okay, show balance, $123.00. If I were to change this to 123.01, we should display 2 decimal places. Yep, $123.01. Okay, that is the show balance function. Let's work on the deposit function. Okay, now we're within the deposit function. I'm going to create a local variable named amount. Set this equal to 0. We'll ask the user how much they would like to deposit. Standard output, enter amount to be deposited. Standard input, our amount. So I'm going to set balance back to 0. Then let's test it. Show balance. 1, your balance is $0.00. I would like to make a deposit. $420.69. Okay, now I would like to show my balance after we make a deposit. So within case 2, after making a deposit, let's show our balance, pass in the balance variable. Let's do so after a withdrawal too. Okay, let's try that again. Show balance, $0.00, make a deposit, $420.69. Your balance is $0.00. So what we're going to do is return our amount at the end of this function. Return amount. $420.69. All right, we have our balance. The user is able to enter in negative money. Enter amount to be deposited, -$1,000. Your balance is now -$1,000. We need to prevent somebody from making a negative deposit. So before we return our amount, let's use an if statement. If amount is greater than 0, then we will return the amount. Else, standard output, that's not a valid amount. Then let's return 0. Okay, let's try that again. Deposit money, -$1,000. That's not a valid amount. Your balance is $0. I'm just going to add a new line, like right here. Then let's make a legitimate deposit. Deposit money. I will deposit $1,000.01. Your balance is $1,000.01. Okay, that is the deposit function. That is complete. Then we have the withdraw function. We'll create a local variable named amount of the double data type. We'll create a prompt, standard output. Enter amount to be withdrawn. Standard input, amount. At the end of this program, we will return amount. Okay, let's test it. Okay, I need to deposit some money first. I will deposit $1,000.01. Then let's withdraw money. I will withdraw $100.01.
My new balance is $900, but we can overdraw our account still. So I'm going to withdraw $1 million and 1 cent. Our balance shouldn't be negative, so let's prevent our user from overdrafting their account. Within our withdraw function, let's add an if statement. If amount is greater than our balance, will display insufficient funds. Then we will return 0. Okay, I'm going to withdraw $1 million and 1 cent. Insufficient funds, your balance is 0. Okay, now what if the user would like to deposit negative money? Withdraw money, negative 1,000. Your balance is $1,000. We'll need to make sure that the amount is a legitimate amount. I'll add an else if statement. If amount is less than 0, standard output, that's not a valid amount. Now, else, we will return the amount to be withdrawn. Then within the else if statement, we'll need to return 0. There. Okay, let's withdraw money. Enter amount to be withdrawn, negative $1,000. That's not a valid amount. That's good. Let's withdraw again. I would like to withdraw $100. Insufficient funds. My balance is 0. Let's deposit some money. $99.99. Our balance is $99.99. Let's withdraw again. Let's try and withdraw $100. Nope, we can't. Let's withdraw again. $99.99. Your balance is 0. That's good. Then let's exit. Press 4 to exit. Thanks for visiting. Okay, so these functions are done. There's just one more thing we should add. If I type in some characters, like the word pizza, well, this will break our program. We'll want to clear the input buffer. So after our choice, let's add these 2 lines. Standard input dot clear function. So I haven't talked about this function. This function will reset any error flags when the standard input fails to interpret the input. Then follow this with flush. This is a function, pass in standard input. This will clear the input buffer. Basically speaking, once we hit enter, we have a new line character within our input buffer, so we just need to flush that and get rid of it. That should prevent our program from going crazy. So let's type in some characters. Invalid choice. Cool. Then I would like to exit. All right, everybody, that is a banking program for some practice. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a banking practice program in C++. All right, everybody, in this video, we're going to create a game of rock, paper, scissors. Let's create our function declarations first. Char get user choice. Char in this case would be the return type. We'll be returning a character. Char get computer choice. Void, there is no return type. Show choice. There will be one parameter, char choice. Then the last function is void choose winner. There will be 2 parameters, char player, that's us, char computer. The computer's choice will be determined randomly using a random number generator. Let's define these functions. Let's copy all of these. After the main function, I will paste them, then add a set of curly braces after each. Currently, if I were to run this program, we do have some warnings because with these 2 functions, get user choice and get computer choice, we're not returning anything, even though we stated that we're returning a character. Just for the time being, I'm going to return 0, just so that those warnings go away, but we'll correct these momentarily. So we shouldn't have those warnings. Within the main function, we will declare two characters. One for player, char player, that's us, char computer, that's the opponent. We will take our player, then assign this a value of whatever is returned from the getUserChoice function. Then we need to fill in this function. Within the getUserChoice function, I will create a local variable of player as well. I'll create a message to begin our game. Standard output, rock, paper, scissors, game. I'll add a new line. This part isn't necessary, but I'm just going to add a bunch of asterisks afterward. Just because I think it would look cool underneath our title. Let's list our choices. Standard output, the character R for rock, new line. Let's copy this. P for paper, S for scissors. Standard input, player. I'm just going to test that this works. Standard output, player. Rock, paper, scissors game. R for rock, P for paper, S for scissors. I'll pick R. That would give us the character R. Okay, so we know that that works. I'm going to place some of this code within a do while loop because the user might not type in R, P, or S. So, do while. I'm going to stick my code within the do while loop. I'm just going to add one more line of output. Choose one of the following. All right, we'll continue this while loop as long as our player does not equal the character R and player does not equal the character P and player does not equal the character S. Then at the end of this function, we will return player. We can't escape this while loop until we pick either R, P, or S. That's how this condition works. Let's test it. Rock, paper, scissors game. Choose one of the following. R for rock, P for paper, S for scissors. I will pick W for wombo. Choose one of the following. R, P, or S. I like the letter X. Nope, can't pick that. Let's go with S for scissors. Okay, S is a valid choice. Okay, that is the getUserChoice function. That is complete. So I'm going to close out of this function. After we assign our player variable, let's display the user's choice. Standard output your choice, :space. Then we will invoke the showChoice function. showChoice. Then there is one parameter. We have to pass in a choice as an argument. We will pass in our player. That's a character. Within the showChoice function, I'm going to create a switch. Switch. We're examining some value against matching cases. We'll examine our choice argument that we receive. If our choice matches the case R, what would we like to do? I'm going to display some output. Standard output, just rock. Then I'll add a new line. Make sure to break. Then case P for paper. Standard output, paper. I'll add a new line. Then break. case S for scissors, standard output, scissors, new line, then break. Let's close out of this function, then test it. Okay, I'll type R for rock. Your choice, rock. P for paper. Your choice, paper. S for scissors. Your choice, scissors. Okay, the show choice function is done. Now we need to get the computer choice. Computer equals get computer choice. Then we'll need to fill in this function. Get computer choice right here. We'll need to generate a random seed. srand. Pass in the time function. Then type 0 or null. You may need to include this header file at the top of your program, just in case this doesn't work. Include C time. We'll generate a random number between 1 and 3. Int num equals rand function modulus 3 plus 1. We'll examine this number against matching cases. Switch. We're examining our num. The first case will be the number 1. If our random number is 1, let's return the character R. Since we're returning a value, we don't necessarily need to add that break statement. We're already breaking when we return. So we can omit this. Case 2, return the character P for paper. Case 3, return S for scissors. Okay, we can close out of the getComputerChoice function. That's all done. Back within the main function, let's display the computer's choice. Standard output, computer's choice. We'll invoke the showChoice function, but pass in our computer. Let's run it to test it. I'll pick R for rock. Your choice, rock. The computer's choice is paper. Let's try it like 2 more times. Okay, we chose paper. The computer chose rock. Let's pick S for scissors. Your choice, scissors. The computer's choice is also scissors. Okay, so the computer is picking a random choice. That's good. Now we'll have to decide who won. At the end of our program, we will invoke the chooseWinner function, pass in our player, as well as the computer. Then within the chooseWinner function, let's create another switch. We will examine our player against matching cases. If our player chooses rock, the character R, I think the best way to do this would be to use if statements within each case. If the player chooses rock, and if the computer chooses R for rock, that means there's a tie. I'll display that. Standard output, it's a tie. Then I'll add a new line. Else if the computer chooses paper, that means we lose. Standard output, you lose. Else, well, there's only one option left, scissors, because if the computer didn't choose rock or paper, that means they pick scissors. Rock beats scissors, so let's display that the user won. You win. Oh, then be sure to add a break at the end to break out of the switch. This is the case if the player chooses rock. Let's copy all of this code, paste it, and let's move this over. Now, if the user chooses paper, we have some different results. Paper beats rock. we'll change this line of output to be you win. If the user chooses paper and the computer chooses paper, that means it's a tie. It's a tie. If we choose paper and the computer chooses scissors, that means we lose. You lose. One more case. If the player picks scissors and the computer picks rock, you lose. Scissors beats paper, you win. Else, scissors ties with scissors, it's a tie. And that is everything. So let's close this function and run this program. Okay, I'll pick R for rock. We picked rock, the computer picked scissors, you win. P for paper. The computer also picked paper, it's a tie. I'll pick scissors. I picked scissors, the computer picked rock, you lose. Well, alright then everybody, that is a game of rock, paper, scissors. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a game of rock, paper, scissors in C++.
We have a big topic today. I need to discuss arrays. An array is a data structure that can hold multiple values. Values are accessed by an index number. Think of an array as kind of like a variable that holds multiple values. It's a little more complicated than that, but that's a good way of thinking about them. Perhaps we have the name of a car. This will be a standard string. I will name this car. Assign this a value of whatever car that you like. One car that I like is a Corvette. Then I will display whatever our car is. Standard output, car. So of course, this car is a Corvette. We can transform this variable into an array by making the following changes. After the variable name, add a set of square brackets, then enclose your values with a set of curly braces. There, we now have an array. My variable car is now an array. Now this variable can hold multiple values, multiple cars, kind of like it's a parking garage. Separate each value with a comma. This time I'll add a Mustang, then a Camry. Now take a look at this. I will display car. Now what the heck is this? So this is a memory address of where our array is located, like 123 Fake Street. If I need one of these elements, one of these values that's found within the array, in order to access it, I have to do so by an index number. After the array name, I will add a set of square brackets, then an index number. The first element in an array has an index of 0 because computers always start with 0. And we have our Corvette. It's kind of like a parking spot number. That's why I went with this example of cars. If I need the next element within my array, I would access element number 1. Then I should probably add a new line, just to separate these. New line. We have our Corvette and our Mustang. Then we have our third element, which would have an index of 2. So we have our 3 elements, our Corvette, our Mustang, and our Camry. You can reassign values too. I'm going to change the first element within this array. Take the array name, select an index number. I'll set this equal to a Camaro, a Chevy Camaro. Now at parking spot number 0, we have our Camaro, then our Mustang, then our Camry. I'm going to rename car as cars, just so people know that it's plural, although it's not necessary. One thing with arrays is that they can only contain values of the same data type. Like I'll try and stick a number within here. Number 1. So our compiler doesn't like it that there's a number in here with all these strings. So arrays should all be of the same data type. Now, if you don't know what you want to place within an array, you can simply declare an array, then assign values later. I'm going to declare an array of cars, and then later assign some values. Cars at index 1 will have our Mustang. Cars at index 2 will be our Camry. See, we still have an error though. Array size missing in cars. You can declare an array, then assign values later. We need to set a size to this array. It's a static data structure. If I'm only going to place 3 cars within this array, I'll set the size to be 3. So within the square brackets, you can set an array size. And this would work the same. You can declare an array, be sure to set the size, and then assign values later. Let's try one last example. I'm going to create an array of prices. These will be of the double data type. Prices, add a set of square brackets. I'll go ahead and assign these values right away, so I don't need to declare a size explicitly. Make up some prices. $5, $7.50, $9.99, then $15. I'll display these prices, standard output, prices. I'll list an index number of what element I'm trying to access. The first would be 0. Then I'll add a new line. Let's copy this line of code and paste it a couple more times. We have prices at index 0. That is the first element. Then 1, 2, and 3. And here are the prices. So yeah, that's an array. Think of it as a variable that can hold multiple values. It's a little more complicated than that. It's a type of data structure, but that's a good way of thinking about them. To change a variable into an array, after the variable name, add a set of square brackets, place your values within a set of curly braces. That's if you're assigning values right away. Or otherwise, you can set a size, and then assign values later. That's another option. So yeah, those are arrays. Your assignment is to post an array in the comment section down below. And well, yeah, those are arrays in C++. You guys ready? All right, let's talk about the size of operator. The size of operator determines the size in bytes of a variable, data type, class, objects, etc. Whatever you would like to find the size of, you stick within the parentheses of the size of operator. Here's an example. Let's create a double GPA. Our GPA will be a solid 2.5. To determine the size in bytes of my variable or a data type, I will just place within the set of parentheses. I'll display this. Standard output size of operator. I would like to return the size of my GPA variable. Then I'll just add a string. Bytes. New line. Let's take a look. The size of my GPA variable is 8 bytes. That's the maximum size allocated to my double variable. If I was to replace GPA with a data type, such as double, well, this would be the same, 8 bytes. This will be helpful in the future when we begin working with arrays. So let's try a couple other variables. I'll create a string, standard string name. Assign some name. Then I will find the size of the string. Size of name. The size of a string is 32 bytes. Because a string really just holds an address to where some text is located. The address of where the string of text is located is 32 bytes. Even if I were to change the size of the string, bro code is awesome. Well, this size is still going to be the same, 32 bytes. Because a string is a reference data type. Let's try a couple other examples. How about a character? Char grade. My grade will be an F. I will find the size of this character, grade. The size of a character is 1 byte. Let's try a Boolean. Boolean, student. Is somebody a student, true or false? I'll place student within the size of operator. A Boolean variable also takes 1 byte of memory. This time, let's find the size of an array in bytes. I'll create an array of characters. Char grades. This will be an array. I'll set this equal to some grades. A, B, C, D, then F. I'll place my array within the size of operator. The size of this array, grades, is 5 bytes. Remember that characters take up 1 byte of memory. An array of 5 characters would be, well, 5 bytes. We can use the size of operator to calculate how many elements are within an array. If we have the total size of our array, we could divide this by the size of one element. Size of grades at index of 0, or otherwise we can find the data type. We'll divide the size of my array grades divided by the size of a character. So I should have these many elements, 5 elements within my array of grades. If I were to add one more grade, like an E, even though that's not a typical grade, well then the total elements within that array would be 6 elements. That's a useful trick to calculate the size of an array, how many elements are within that array. One more, this will be a bonus question. I'll create an array of strings. I'll name this students. We'll enter in some student names, such as SpongeBob, Patrick, then Squidward. To calculate how many strings are within this array, how many students we have, we can find the size of my array students divided by the size of a string. I have 3 elements within this array of students. Then I could add one more. And this equation should calculate that. I'll add Sandy. Size of students divided by the size of a string would give me 4 elements. So yeah, that's the size of operator, everybody. It will return the size in bytes of a variable, data type, class, objects, all sorts of things. It will be really helpful when working with arrays because we can determine the size of an array, but we'll get some practice with that in the future. And well, yeah, that's the size of operator in C++. Alright guys, in this video I'm going to show you how we can iterate over the elements of an array. Suppose we have an array of students. These will be strings. Standard string. I'll name this array students. Set this equal to some student names. Pick a few. SpongeBob, Patrick, then Squidward. Suppose I would like to display all these students. Normally to do that, I would type standard output my array followed by an index number. So the first student would be SpongeBob, which has an index of 0, and my first student is SpongeBob. If I need to display all of the elements of this array, I would have to one by one access each element. Then I'll just add a new line. We have SpongeBob, Patrick, and Squidward. If I need to display all of the elements of an array, a better approach would be to use a for loop. I'm going to type for, parentheses, curly braces. We'll need an index, int I. I'll set this equal to 0 because the first element in our array has an index of 0. I'll continue this as long as I is less than the length of our array. Currently it's 3. Then increment I by 1. During each iteration, I would like to display each element. Standard, output, students. Now instead of an index number like 0, 1, 2, or whatever, I'm going to use my counter variable, I. Students at index of I. During the first iteration, I will be 0, then 1, then 2. Once we reach 3, we'll stop. I'll add a new line. This for loop will print the elements of my array. SpongeBob, Patrick, Squidward. There's one issue with this though. What if we add another student? Such as Sandy. Well, this for loop will stop once I reaches 3. If we make any adjustments to this array, we would have to go into our code and make some changes, such as setting this for loop so that we discontinue when I reaches 4. This would work, but it's not the best solution. For our stopping condition, in place of just setting I to be less than some number, let's calculate how many elements are within this array. To do that, we can use the size of operator. I'll type size of my array. This will give me the total size in bytes of my array. To calculate the number of elements, I can divide size of students by the size of the data type, string, or even an element. This will loop through all of the elements of this array. SpongeBob, Patrick, Squidward, Sandy. If we change the number of elements, well then there's no need to touch this for loop. It will calculate the size automatically. See, now we just have SpongeBob and Patrick. Let's create one last example. I'll create an array of grades. Char grades. We have an A, B, C, D, then F. If I need to iterate over this array of characters, I would find the size of my array, grades, divided by the size of a character, the character data type. During each iteration, I will display grades at index of I, our counter. And this will display all of the elements of this array. So yeah, that's how to iterate over an array using a for loop. In the next topic, I will explain the for each loop, which has different syntax. And well, yeah, that's how to iterate over an array using a for loop in C++. Alright guys, the for each loop. The for each loop is a loop that eases the traversal over an iterable dataset. An array is an example of an iterable dataset. Suppose we're using a standard for loop, and I have this array of strings named students. We have SpongeBob, Patrick, and Squidward. Using a standard for loop, I would need 3 statements. An index, a condition, then we could increment or decrement our index. This does work, but there is another way of writing this using a for each loop. There's less syntax than a typical for loop, but it's less flexible. Using a for loop, we can go forwards, backwards, or even skip iterations of something we're iterating over. Using a for each loop, we start at the beginning and go to the end. There's less flexibility. So let's change this to a for each loop. First, we'll add the data type of what we're iterating over. We're iterating over strings,